Hey guys, this is continuing on Unit 2. So today we'll be talking about trends of the periodic table. Make sure you fill in your notes as we go. The periodic table is arranged according to periodic law, which we discussed a little bit last class. This just says when elements are arranged in order of increasing atomic number, which is how our periodic table is, their physical and chemical properties will show a pattern. Our first trend is atomic radius. This is the distance from the center of an atom in its nucleus to the outermost electron. So it's kind of measuring the size of an atom. As you go down the periodic table, as you go down the groups, the atomic radius increases. And as you go across towards helium, it decreases. So as you move down a group, you add more energy levels, which is making an atom bigger. Electrons are going to start to be farther away from the nucleus. The inner electrons act as a shield to those outer electrons, and they can reduce the attraction between the positively charged nucleus from the protons and the negative electrons. It basically makes the atom spread out and become bigger. When you go across a period, you add more electrons to the same energy level. You're also adding more protons. Both are added in the same energy level though, so electrons aren't really going to get shielded in this way. The charge of the added protons actually pulls the electrons closer to the nucleus, so that's making your atom smaller. So here's kind of what that looks like. You can see that as you go down on this chart, your atoms get bigger, and as you go across, they get smaller. So in this picture, my biggest atom would be Cs, which is cesium. Next trend is electronegativity. This is the tendency of an atom to attract an electron and make it part of its orbital. Elements on the right side of the periodic table really want to grab another electron, and so they have really high electronegativities. Elements on the far left side of the periodic table are the opposite. They really want to get rid of their valence electrons, so they have low electronegativities. It doesn't take much for group 1 and 2 to get rid of their electrons. The noble gases, they don't care about their electrons because they're happy. They have 8 valence electrons, so they have a full outer shell. So they have no electronegativity at all, and we just say that those are stable. So electronegativity increases as you go up groups, and it increases as you go across. So the most electronegative element, which we will label on our periodic table, is fluorine. Why does this happen? So elements on the right side of the periodic table really want to gain electrons. Elements on the left side really want to lose electrons. Noble gases don't need to gain or lose, so they're stable, they don't change. So this really just happens because elements want to have a full valence shell, and to get to that full 8 in their valence shell, they have to gain or they have to lose electrons. The difference in electronegativity can also be used to help classify compounds. So we won't really get into that this year, but next year if you end up taking Chem 2 or if you take chemistry in college, you'll learn this. So if there's a difference in electronegativity, if it's around 0.4 or less, we call that a nonpolar covalent compound. If it's between 0.4 and 1.7, it's polar covalent. And if it's more than 1.7, that's probably an ionic compound. So here's kind of what that actually looks like. This periodic table has the electronegative units. So like fluorine has electronegativity of 4, chlorine is 3, bromine is 2.8. So this kind of just shows that. Our next trend is ionization energy. This is the amount of energy required to remove an electron from a neutral atom. It increases as you move up a group, and it increases as you go across. So our arrows would look like this. Why does this happen? So again, 8 valence electrons is a happy number. That's to make an atom stable. If an atom has only 7, Would it be easier or more difficult to take an electron away? If it has 7, it's going to be very stingy with those electrons because it's so close to having 8. All it has to do is gain 1 more to be stable and happy. So it's going to be very difficult for anything with 7 valence electrons to lose electrons. Yeah, it only needs 1 more electron to become stable. Our next trend is called ionic radius or radii. It's half the distance between 2 ions that are barely touching each other. The ionic radius might be larger or smaller than the atomic radius. It just depends on the charge. Cations are typically smaller, so cations are usually your metals, than neutral atoms because an electron is removed. The remaining electrons are more tightly drawn in towards the nucleus. An anion has an additional electron, so that increases the size of that electron cloud or that energy level, and it makes the ionic radius larger than the atomic radius. So ionic radius is really when we're talking about anything that has a charge. It may have more or less electrons than it usually has. So again, it increases as we go down and it decreases as we go to the right. Why does this happen? So cations, as you take away electrons, the positive charge of the nucleus has more of a pull on those inner electrons. This is very similar to the atomic radius. Anions, same thing. If you're adding electrons, the nucleus has less of a pull on them, so it's going to be a little bit bigger. Last trend is called reactivity. Reactivity is the tendency of a substance to undergo a chemical reaction, either with itself or with other materials, and there will be energy released. All right, so that's it for today. For reactivity, really just groups 1 and 2 are super reactive. Everything on the right side is a little bit less reactive. So anything that had a periodic table like this with the yellow arrows, we're going to draw those yellow arrows on your periodic table. So go take a look at my periodic table picture on the website and make sure you have everything labeled.